Hey guys, this is exercise 8D, analyzing financial situations using amortization tables. Hopefully you received the handouts for this. You've got them in your exercise books and you're watching this video in order to fill in the notes. So 8D extending on 8C, amortizations. We're going to be looking into amortization tables and what happens when we get to a final payment of an amortization table. And we're going to see how this works for reducing balance loans and also annuities. And we're also going to be finding the total payment made or received and the total interest paid or earned, and also be able to plot these points for an amortization table for reducing balance loan, an annuity, and also compound interest investments with additional payments. So jumping straight into example 15, hopefully by now you've got the notion of how amortization tables work. Here we have an example for a balance for a loan, a $20,000 loan. This has an interest rate of 8% per annum compounding annually. And this is going to look a little bit unusual, but there are regular payments of $5,009.12. Now the reason why this payment looks quite bizarre and not just rounded down to 5,000 is this question has been designed so that on the fifth payment, specifically the fifth payment, the balance is going to reduce down to zero. So the way this has been worked out through brute force is they've figured out the best amount for this repayment to happen, so the balance goes to zero on the fifth payment. Now here we have the amortization table. We got your payment numbers, your locked in payments. This is always locked in depending on what the bank or financial institute has decided to provide or for you to give to the bank. And obviously interest is being worked out. As the payments keep going, the interest amount will decrease. It will start at a very high amount and then decrease down because your balance is going down, which means how much you're reducing the balance is going up. There's this kind of compensation going on. Now what this question is requiring us to do is to be able to calculate the final payment required in the fifth year to fully pay off this loan. So effectively, on the fifth year, this balance is going to be equal to zero. Now, what we're allowed to do is, effectively, when it comes to the last payment, we're allowed to use a key to unlock this fixed payment amount and change it or shift it accordingly so our last payment can fully pay off the balance. Now this could mean that one of two things could happen. Your final payment will just be a little bit more or a little bit less than what you intended on having that payment to be in the first place. So we'll find out what this payment happens to be. The first thing we need to know is how much interest is going to be put on the remaining balance. So we know that this is at an 8% per annum compounding annually. So there's no compound breakups in like 12s or quarterlies or anything. This is just 8%. And what we need to do is find 8% of this amount. So we're finding 8% of the remaining balance, which is $4,638.12. Or in other words, we're finding 8 of 100 times this amount here. When calculated properly, you should get an amount of $371.50. So this is how much interest that needs to go to the bank before you pay off everything else. Now, we've got a new calculation that we have to deal with. We know that this is going to be the last repayment because it's saying in the question, calculate the final payment required in the fifth year to pay off the loan fully. So we don't owe anything to the bank. If we know that this balance here is what's remaining, and we also know that we have to provide this in interest, if you add these two amounts together, this is how much we're going to pay to the bank to fully pay off this loan. So we'll pay back what's remaining plus the bank's interest add those two together, and this will give you how much you have to pay for your final payment. So we have a new calculation technically. And this is this key going into the lock to unlock that payment amount and shift it ever so slightly because we're compensating for this final amount. So I'll put a different color. Let's make it blue. So the new calculation is technically how much is owing. So our balance here, plus the interest that the bank requires. In other words, the bank, we are owing $4,638.12. And then the interest, what we just worked out, $371.50, will yield us a total amount of $5,009, which is eerily similar to what the payment is, and 62 cents. So there's this additional or extra 50 cents that will be needed to pay off this loan. Some banks might change that process and require you to pay off $5,009.12, and then your next repayment is just a measly 50 cents. But seeing as though that in the scheme of things, proportionally speaking, 50 cents is very, 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 very small. So you might as well just pay it off. So this new calculation of how much is owing is a little bit different, and because we're unlocking this payment key. Example 16, we're going to consider the following amortization table. And this is for a reducing balance loan of $10,000. Interest rate of 8% per annum, compounding quarterly. So we've got to change that 8% just a little bit. Three quarterly payments rather of $2,626 has been made. And we want to look into what this last quarter payment will need to be for the payment, the interest, and the principal reduction, so we can get this balance of $2,575 down to $0. Now, when we work out this question, this is actually going to be worked out in a different order. So we would be so used to going A, B, and C. With this being our last payment, this $2,626 is now being unlocked, and we're going to alter this. So we're actually not going to work out A first. A is going to be worked out a little bit afterwards. First things first, let's have a look at the question. Complete the amortization table corresponding to payment 4 such that the final payment ensures that the balance is 0. Calculate the total payment made for the loan, and then calculate the total interest paid on the loan. I'm just going to hit this all in one go. So the first thing we need to do is we need to figure out how much interest needs to be given to the bank. And this interest is a quarterly compound of 8% on the remaining balance. So we're just going to work a little bit backwards here. If 8% is the per annum, if we're going to compound this quarterly, 8% dividing this by 4, because there are 4 compounds within a year, gives us 2% per quarter. 2% per quarter. So we're going to be using 2% as our interest working out. The next thing we need to do is we need to figure out what 2% of the remaining balance is. So we're going to find out what 2% of $2,575.40 will give us. So 2 over 100 times $2,575.47. This will give us an interest amount of $51.51. So we automatically know that $51.51 needs to be worked out, or needs to be used, as an interest amount, and we've got to take this into consideration when we use our principal reduction. Now the thing is, for a balance that's at $2,575.47, for it to go down to $0, C has to be $2,575.47. This is the only amount that it can be in order for the balance to reduce down to 0, that this person has nothing owing. So we've worked out C, we've worked out the interest. How do we work out what the payment is? What does the payment need to be in order for a principal reduction to be locked at this amount here? And how we work this out is if we know that our payment or the balance, this amount here, needs to be paid plus the interest to get C to be locked in, all we're doing is just working out this amount here plus the principal reduction. So let me say that again. A, how much the payment is how much you had to give to get the balance down to zero in the first place, which is $2,575.47, plus the additional interest of $51.51. This here will give you the payment $2,626, really similar, and 98 cents. This here is what the final payment will need to be. So it's whatever the balance is, plus that extra little bit of interest, because it's a percentage of what the remaining balance is, will give you your principal reduction of this amount here. Because if you subtract these two amounts, you will get this amount here. And when that gets subtracted from the remaining balance, it will yield a new balance of $0. So this person doesn't owe any money to the bank. The last example is just looking into plotting the amortization table with the interest and the principal reduction on the same graph. Now, this is taken straight from the textbook. The blue dots, this is the amount of interest that's owing. We expect that if we have a loan of some sort, that the interest amount, as the payments keeps going, will go down because you're owing less interest each time you pay down in the principal. And then as a reaction to that, the amount that the principal is being paid, the red dots, these will increase. This will go up because you're paying off the loan more and more and more. So this amount keeps going up. So you're gonna see this trajectory that's gonna split off into two directions as the amount of payments goes on. Something to make sure that you hone in on skill-wise, because this will be a part of your SAC. All right, for you guys, you will need to tackle questions 1, 3, 6, and 9 for exercise 8D. Best of luck.